Hello, everyone. Very good afternoon to all of you. I, Preeti Kashyap from Eschan Publishing, welcome you all to the third session of day one of Mathematics Summit, second edition. So in this session, we will talk about the key challenges in teaching mathematics, where our expert speaker, Ms. Saryu Dahiya, will be telling us about her various ways to tackle those. I'd like to tell you about our speaker expert for this session. Ms. Saryu Dahiya has been in education for past 15 years and has mentored and guided students of all grades to recognize their potential and work towards it. She has worked with esteemed schools in North India. She also imparts training to teachers in mathematics and is the founder of Aryan Academy, an IELTS learning center. She graduated in mathematics honors from Lady Shri Ram College, Delhi University, and holds a B.Ed degree. So before I hand over the mic to Ms. Saryu, I'd like to mention some housekeeping rules to you all. Participants will be muted throughout this entire session. Please ensure you have a pen and paper to note important information. The chat box will only be enabled during the Q&A round. To receive your e-certificate, please fill out the feedback form that will be sent to you on your registered email ID after the Math Summit. The lucky draw and quiz will take place tomorrow at the end of the summit. That is at 5 p.m. All the participants stand a chance to win Amazon vouchers worth up to rupees 40,000. So please don't miss any session. So let us all welcome Ms. Saryu Dahiya. Ma'am, over to you.
Am I audible?
Yes, ma'am.
All right. Thank you so much, Preeti. Thank you, Preeti, for this wonderful introduction. And a very good afternoon to all of you present here. I'm Saryu. I welcome each one of you to this another session of Math Summit 2023, organized by Eschan Publishing. I also thank Eschan Publishing for providing this interactive platform to share my views. I know most of you have attended these back-to-back sessions of maths and have picked up your points. In this session also, I would try to make it interesting and enriching for each one of you present here. So let me share my screen now. And also I'll be keeping my video off. All right, let's start. The topic of today's discussion at this hour is nature of mathematics and key challenges in teaching this subject. Now, I would like to start with a quote here by one of the greatest philosophers of 17th century, Galileo. He was also an astronomer and a great physicist. According to him, the laws of nature are written in the language of mathematics. Let me read it once again. The laws of nature are written in the language of mathematics. Now, what did he mean by that? We all have our own versions. As I have understood, let me explain through an example. If you look at this picture, it's a river delta, a beautiful piece of geometry. When we hear the word geometry, the images that come to our minds are 3D geometrical shapes like cubes, cuboids, circles, triangles. Now, geometry is definitely the mathematics of all shapes. And this meeting of land and sea has created shapes with an undeniable pattern. It has a mathematical structure. If you see closely, every small part of the river delta with its twists and turns is a micro version of the greater whole. Now, I would like to compare this river delta with another pic of trees. Trees are wonder in themselves. If we compare these pictures, we can see the similarities in the pattern of branches of trees and the river delta. Now, these are totally two different things. Then why should these shapes look so remarkably alike? Why should they have anything in common? Now, things get more interesting when we realize that it's not just the water systems and plants that do this. We can see these shapes are everywhere. Another example, let me give you another example that exhibits the same pattern. Lightning bolts. Lightning bolts disappear so quickly that we hardly have any opportunity to ponder on their geometry. Here also we can see that every extension is a micro version of the greater whole. Are they not similar? Now let me show you another structure. Structure of veins. These are just examples I'm showing you with the same kind of geometrical shapes in them. Structure of veins. Are these not similar to the structures that we just saw? Same pattern. Now, if we start looking for such patterns, then I would say we humans are also filled of these shapes. Every cubic centimeter of our body is packed with what we call blood vessels that trace out the same pattern that we just saw. Another case, even the neurons, our brain cells, they also exhibit the same pattern. So, will it be wrong to say that there is a mathematical reality woven into the fabric of the universe that we share with these winding rivers, towering trees, and raging storms? Now, these shapes are nothing but examples of what we call fractals. It's a mathematical term. I'm sure all the mathematics teachers present here, they are familiar with this mathematical term given by our mathematicians. Fractals. Now, if you see this picture on the right-hand side, it's an example of a fractal. Exactly each part is a micro version of the greater whole. Like all the pictures that you've seen, there is a similar same thing, and it is the fractals they represent. So fractals get their name from the same place as fractions and fractures. It's a reference to the broken and shattered pieces we find all around us in nature. Now, once we have the sense of fractals, we really do start to see them everywhere. So in order to reach there, a child does start. Now, I have shown you a big picture. Now, let me come down. Let me try to connect it with the things that we do it in the class. So in order to reach there, a child does start his journey of understanding through the concept of fractions, right from class 2 and 3. And we as educators, we also start teaching the child from the live examples all around them. Just like these, in fruits, in sandwiches, in rotis, in chapatis, in our day-to-day lives. Then we take the child through its pictorial form. You can see how beautifully the fractions have been represented in the vertically, horizontally, in a circle. And finally, we take the child to its abstract level where the child is able to understand the different mathematical operations related to fractions. Here, I've just taken an equation because this becomes the abstract form and is able to do them correctly. So we have taken the child right from the concrete pictorial now to the abstract part. But before the child is fully ready, fully able to understand, make connections, and is able to communicate his ideas, we introduce him to something like this, story sums. And the child is definitely left with this. In most of the cases, not in all of the cases, I'll say, but yes, when the matter of story sums comes, it's a difficult task for us teachers. And then we are left with the question, what went wrong? The magic that started for the child suddenly disappears, and what he is left with is a little disappointment, isn't it? Now, before I start off with the key challenges, let me show you one more phenomena in nature, a miracle in itself. It's just a 1-minute video, right? Just have a look. In this video, what you'll see is the process called murmuration. Here you can see it's a starling murmuration. It's the gathering of tens of thousands of starlings, where they take to the sky, performing their dazzling aerial display. They all move together as one entity, creating lines and shapes as they blacken the sky. Isn't it beautiful? These breathtaking shows can last anywhere from a few minutes to close to an hour before ending suddenly as they nestle into their roosting sites before dusk. Now, this sight is very much common in countries like UK, North America, and some countries of Europe. Isn't it beautiful? Now, what is this? The thing that I showed you is called murmuration. Now, it's nothing but the phenomena when huge flocks of birds in migration form shape-shifting flight patterns. The process is called murmuration. It is one of the nature's most magnificent shows of birds swirling in the sky as if they are thinking with one mind. Now, scientists tried to figure out how they can fly like this without even colliding with each other. And they came to a conclusion that it is only possible when each bird can do about 100 million mathematical calculations in 1 second in order not to hit each other. So I would say it's one of nature's greatest and most fleeting phenomena. Nature never stops amazing us. I would say one of the wonders of natural phenomena where maths is doing the talking. So yes, maths is a language to communicate with each other. Now, I would say maths is not only present in nature all around us, but it is also a human language, a scientific language, just like other languages where like English, Hindi, Spanish, Chinese, because it allows people to communicate with each other, isn't it? Will it be wrong if I say that kids don't understand maths because we have been teaching it in a little as a dehumanized subject? In ancient times, our people needed the language of maths to build monuments, to conduct trade, and to measure the land of farming. So the idea of maths as a language isn't new. But somewhere along the line, we have taken this language of maths, which is about the real world, and we have abstracted it beyond recognition. And that's why kids are confused. And their confusion leads to the challenges which we face in our classes to teach the subject. So to start with, if we start teaching, just for an example, I'm saying, if we start teaching our kids, suppose addition, then it should not be like 1 to 1 is 1 plus 1 is 2. Rather, it should be like 1 apple plus 1 apple is 2 apples. 2 apples and 2 oranges and 3 oranges are 5 oranges. So that when the child reaches to the level of algebra, he is able to configure that 2x square plus 4x square equals to 6x square simply through logic and intuition. So we have to put more efforts in making this subject humanized in a more interesting and a humanized way. So I will say in these pictures, the video and the pictures that I have tried to show you, I have tried to show you a bigger picture. Whereas bigger picture of maths and nature, it's everywhere. But do we take our students to this level? Do we motivate them and then get into the details of the concept of fractions? Or is it the other way around? First, we get into the details and then we try to show them the bigger picture. I would like you to think about it. We educators need to ask ourselves this question and then move ahead accordingly. So I have shown you a bigger picture. The nature, like the Galileo said, the laws of the nature are written in the language of mathematics. So yes, that's a bigger picture. So do we show the kids that bigger picture, or do we show the details first and then we take it to the bigger picture? So think about it. Now, after building up your interest, let me take you to the key challenges in teaching this subject. Right? We all are familiar with it. So the first and foremost that I would like to talk about is the real life connect. Now, I ask how many of us come across the statement in our class that, ma'am, where will I use this in my real life? Why do we even we have to study this? Because I have come across it many times, especially in classes third, fourth, and fifth. So I would say some of us, or almost all of us, must have come through this statement that, ma'am, why do we have to study this particular concept? Then I will say it's a red flag for us. Either the child is, either I'll say the child is not able to understand the concept at all, or he's not able to solve particular problems, right? Or the child is not able to see or apply that particular concept in his life, or it is a previous concept that he's not able to connect it with, or it can be all of them. So hearing such statements should not be avoided, that where if the child is not able to see a real life connect, then it's a red flag, because clearly the child here is not able to solve and he is definitely going to lose interest. If the child starts losing interest in the classes like 4th, 5th, and 6th, then definitely by 9th and 10th, they are going to drop it. because their interest means a lot, right? In fact, let me share an example with you here, my own experience. Like in my initial days, like when I was teaching a particular topic, I don't remember the topic, maybe it was fractions only. A child had come to me with the same thing that, ma'am, where will I use this? So I was trying to explain the child that, this is what happens. This is what happens. See, I did this with you. See, I tried to teach you this. But ultimately, the child was saying, yes, yes, okay, okay. But how much was he understanding? I was doubtful that he was understanding anything because I was doing the talking and he was doing the listening. And maths is not about listening, it's all about doing, right? So, definitely, if we are hearing such things where the child is not able to make a real life connect, then we need to do something about it. So the things that we need to think about here is, as an educator, as a mentor, that we should try to get into a little deep into the topic. Is it the concept the child is confused with? Or is it the process the child is not able to understand? Process, I mean to say here, is the procedure, the steps involved. Is it its application? Application, I would say definitely story sounds. Is it only that, real life connect? Or is it the gap in the previous knowledge? Where if the previous knowledge, if there's some other concepts are involved, then is it that? It should be out of all these. Out of all these, one, we should be able to pinpoint, like, where is the problem? Not just by saying, okay, I'll explain it to you later. Explanation here can help to a certain level. I would say explanation part does much better in classes like 10th, 11th, 12th. But if we are dealing with the smaller kids, 3rd, 4th, 5th, maybe a little younger to them, then it's not, the hearing part will not make much difference, right? So whenever we are introducing a concept in the class, try to show its application in real life. And don't limit yourself to few examples that are given in the text, right? We all have access to our textbooks, but try to do it, give examples from your experiences and surroundings. You being the teacher, you being the mentor, you have to pick up examples from your experiences and surroundings. Because the more the child is able to connect the concept with his surroundings, the more he will understand the concept and its application in life, right? Again, I would say, let's say I would like to take example of fractions. If we are teaching this topic, then the examples that we normally take are of fruits, pizzas, chocolates, sandwich, chapatis. That's good. But try asking them the questions like, how would you divide a leaf into 2 equal parts? How would you divide pencil? How would you divide your eraser, your bag, your tiffin box, your pencil box, your favorite toy into 2 parts, into 4 equal parts, into 3 equal parts? Some will divide it, do it horizontally. Some will try to do it vertically. Some will try to do it diagonally. Now, such out of the box questions will make them think. It will make them help them to make connections. And the answers need not be right. It's not just that we are looking towards marks. We are pushing them to look around. We are pushing them to think. We are pushing them to make connections and patterns. So this should be our aim, not the marks at this level, right? So I would again say, think about it. How would you want to go about it, right? Now, another key problem that we teachers face is definitely off-word problems, right? I'm sure each one of you will agree with me here. Yes? Okay. Now, word problems have always been the toughest part to deal with. Even with the brighter kids, I will say at a point it becomes challenging for them, right? And there are those kids who who only attempt direct questions. Okay, if the question says do the addition, subtraction, multiplication, division of factors, multiples, fraction, whatever, if the question is asked directly, they are able to do it. But if the same thing is asked in a story sum in the form of a word problem, then they get confused and they mix up things. And if this becomes a pattern, then they build up the tendency to leave the problem. And eventually, grades get affected and they lose interest in the subject. But if the child is, now here the red flag is, if the child is comfortable doing only the direct operations and is reluctant to attempt story sums, it means that the child has understood the steps, the child has understood the procedure, the process involved in solving that mathematical operation, but the conceptual clarity is incomplete. Now, to explain this further, I have taken an example, a very simple example of 1 by 2 divided by 1 by 4, right? Now, here, what do we teach the child? That in order to solve, in order to divide one fraction by the other, what we have to do is we have to change the division sign to multiplication, and we have to change we have to take the reciprocal of the second number and then do the cutting, and ultimately you get the answer, whatever you get. Now, but because I will say this is the way even we have learned in our classes. This is how our teachers, our mentors have done it. And they were right also. But it's the process. Here, do we tell the child why this division sign gets converted into multiplication sign? Do we tell the child why do we take the reciprocal of 1 by 4? And in extreme cases, I will say, I'll give another example. Like, see, here 2 fractions are getting divided and the answer is a whole number. Now, not that every child will question this, but there are those who are in a habit of questioning, and they will do wonder how come the question is of fractions and the answer is a whole number. Isn't it a thing to think about? The question is of, now we as teachers, we know that, but does the child know? In his own understanding, he is trying to do this. What he's trying to think is 2 fractions are getting divided and the answer is a whole number. Why? So, but most of the cases, what happens is he knows the process, he gets the correct answer, he gets the marks, he does not bother. But the mixing up happens when the problem sums comes. It's that part that is more disturbing, as they have not understood how the division happens in fractions. What should he look for when dividing one fraction by another? That makes the concept of it. Otherwise, they'll get stuck. I feel it would be better if we show the child this division in real life situation and clearly state the meaning of division before doing the division. So rather than saying 1 by 2 divided by 1 by 4, I think child should always be encouraged, should always be taught how to state the division problem, that how many groups of 1 by 4 can come in 1 by 2. How many groups of 1 by 4 will fit into 1 by 2? Actually, the question is that. Now, what we are trying to do here is we are trying to read it through mathematical language, right? So if we use here the language, normal language, so if without even showing you on in a real life situation, if I say how many 1/4 do fit in 1/2, clearly the answer that comes to your mind is, oh, there are two of them. So this is how the child should be able to visualize. And this visualization will only happen when the child sees in his real life situation, right? So word problems, in order to deal with word problems, it's the concept that matters. The conceptual clarity has to be there. Otherwise, we are going to face problem in making them understand. Okay. Now, one more challenge that I would like to talk about here is handling a mixed ability class. All right. Now, here I will say, in terms of students with different IQs, in every class, we have a couple of, I'm sure all of you are relating with me here, the cases that I'm taking. In every class, we have a couple of bright kids who finish their work before time and have their answers ready. And they have answer to every question. And there are always a couple of those also who struggle at every point. So this is what I'll say. We always we are always dealing with mixed ability classes, right? So personally, for me here, the challenge was always to handle the brighter lot. That is, how do I keep these kids busy while I deal with the rest of the class? That is a big challenge. And I'm sure some of you do agree with me here, right? So now with the kids with different IQs, they comes different energy level. So definitely we can't deny this, right? And kids with different conceptual background, that is knowledge of the concept. Conceptual background here, I mean, is how much the child knows at personal level through his experiences from surrounding environment, right? The child comes with a basic knowledge to the class of his surrounding, of his personal experiences. So that also makes a lot of difference. And then with the previous knowledge understanding. Now this definitely, if we have already started and the child is not okay, not thorough with the previous knowledge understanding of the topics, then this is definitely going to affect the speed of the child and definitely the speed of handling the kids. So yes, this is also a key challenge in teaching this subject, right? So how do we do this? We all are facing this. So let's see, how do we handle such challenges? There are things that we need to remember as teacher. I would say for solving any kind of problem, the conceptual clarity of the topic is the base. And I'm sure in all the sessions today and tomorrow, you are going to hear the same thing from all of us, that the core, the base of everything is the concept clarity of this, of any topic. Once the child is familiar with the concept, then rote memorization helps in better understanding. It's not that rote memorization is wrong, it's good. But first should be conceptual clarity and not the rote memorization. For example, I'll give you, when a child comes for admission, like his parents, they take a lot of pride in saying, oh, my child knows table till 12. My child knows the table till 15. But that is only rote memorization. How much the child has understood, we are doubtful. That does he even mean what is 15 times 7 means? It's just a rote memorization. So the exam, I have also taken up the example of, suppose it's the topic of multiplication. So if we are doing rote memorization of tables also, child should know, first of all, why is multiplication even required? At first, what is the need of multiplication in our lives? Why did it come? How did it origin? What made it? It is the addition. When the addition gets lengthy, that's how the role of multiplication comes. So the need of that topic is very much to be introduced in the class. And then suppose if it's the definition of multiplication, like we do definitions in all the subjects, definition does matter. It's not the formula only that matters, the definition of multiplication. Now, if we say 5 times 3, the child should know what 5 means, what 3 means, what is the position of 5, what is the position of 3, why there is a cross sign, how do we read it? It's actually 5 times 3, which is nothing but 3 is repeated for 5 times. So it's the language. So when kids are doing 3 plus 3 plus 3 plus 3 plus 3, they quickly realize that the repeated addition is slow and it's inconvenient, and they gladly memorize it. So rote learning should go hand in hand with the conceptual clarity, not before it, right? So yeah, I've taken the example of multiplication. So these are the things. After definition, formula should be there. Then the application of that thing. And once we have done multiplication and division, then we should be able to tell the child how is this different from the concept of division also. So all the concepts should be touched upon. It's not just, okay, child knows the multiplication, child knows how the tables, child know how to multiply in the old fashioned way. So, he knows. No, all these concepts need to be taken care of. They should be touched upon. Then only a full understanding, then only once the child has done multiplication, he or she will be able to take it further in terms of exponents. So if you see addition, then multiplication, and then exponents, they all are in the same line. One thing, the origin is the same. So, and child should be able to make the connections, right? So, conceptual clarity definitely has to go hand in hand with rote memorization. And for the junior classes, especially from say nursery to 5, all the concepts should be introduced through an activity. This is what I believe, where the child is involved, and the involvement should be in such a way that he goes through an experience where he sees, he touches and feels. And after the experience, child should be able to give time to make connections, patterns, relationships in his mind. And finally, should be able to communicate his thoughts, experiences, and is able to apply in his real life. So this is how, and activities should be given time. It's not, these activities I'm talking about are not warm-up activities. These are definitely the conceptual activities I'm talking about. Now, whatever we have talked about it, these are in a way categorized by NEP and NCF in the terms like strategies like the learning of the child should be activity based. It should be a playway method to teach mathematics. It should be an experiential learning for the child, and there should be a real life connect, so that there is a holistic learning. So whatever we are talking about, it's a mixture of all the concrete, pictorial, and abstract things, starting from the concrete part, where the child is able to see, feel, and do things with his hands. So On one side is NEP and NCF, the other, the same thing has been said in different language through another concept of teaching mathematics, which is nothing but CP approach, which we also call Singapore maths. Now, Singapore maths also consists of three things: concrete, pictorial, and abstract. Concrete is action-based, pictorial image, and abstract is nothing but which we have been doing all our lives, right? So now this CP approach, let me just quickly take you through this. The CP approach has been given by an American psychologist, so Jerome Bruner, where he talks about this. So children do need to experience a mix of all these three modes, which are enactive, iconic, and symbolic. If the learning of any concept happens, the understanding of the abstract level will always be, according to him, the understanding of the abstract level will always be better if the child goes through the concrete and the pictorial part first. All right, so this is again, NEP and NCF also talks about the same thing, but in a little different language. So now, when we do the activities, the major thing that we have to remember is the working should be done in the groups. And whenever we do any activity, why it is preferred that we should do these activities in groups? Because, and especially in groups of 4 to 5 students, in a group, there shouldn't be more, otherwise learning doesn't happen. The shy kid will never be able to open up that much. In group of 4 to 5, each child gets a role to play. So the groups, and secondly, the groups should be heterogeneous. That means some brighter kids, some non-brighter kids should be together. Kids of different IQs should be grouped as the kids learn more through their peer group. Now, and definitely they are comfortable in the company of their friends. Another point that we need to remember as teachers, the instructions should be simple, short, and to the point. And once the activity is done, the closure of the activity should have an end product. That means the objective of the activity, why am I asking the kids to do this? What learning? That is really important. So the activities should be followed by pictorial and presentation, and finally the abstract part. So working in groups is definitely an important aspect of learning. And next thing is the 4 C's, right? The 4 C's of 21st century skills, which are nothing but communication, collaboration, creativity, and critical thinking. These are the things that, these are the skills that are being worked upon when a child works in groups, right? So this is the importance of groups. When we talk about assessments, when the time of assessment comes, child should be tested at multiple levels. It's not we have given one sum and then I can check. What are the different levels of assessment? Child should not only be tested at the level of definition, that is the definition of concept in words. Then representation of concept in mathematical language, that's the formula. Yes, definitely child should be tested for that. Should be tested for the steps, for the direct problems, then story sums, and definitely connection with daily life. Now, so connection daily life, definitely it's a hot question. So how we are assessing the child also matters. The question should be asked in such a way that the concept becomes clear to the child and not only the process involved in it. Now here I have a little different approach also. Like whenever when we are dealing with kids of different IQs, mixed ability classes, then we can have this is just a suggestion. You take it or you don't take it, that's all up to you, right? When we are making a question paper, it will be better if we make at least 2 sets of the same paper. So if you'll ask me, oh, do we have to make the different question paper? No, question paper can be the same with a little difference. The difference can be the advanced learner can be given the question paper as it is, whereas the basic learner can be given the same question paper with a little hint, and the hint goes to you. Okay, if I'll give a little help with the child, it'll help him. So we have to remember the aim is not here to get marks, not 100%. It's the understanding of the concept that is what matters. So do also think about it in terms of assessment, right? Now, I would say we are nearing the end. So let's try to take a full picture of what it is. As in any subject, if the child understands the concept, the topic, then he is able to answer the questions. So same goes with maths. If the child understands the concept in maths, then he'll be able to answer the questions well. In fact, in maths, I will say that we have an added advantage of formulas. Even if we don't understand the concept, we can use a formula through rote memorization and get marks. But when use of these formulas take the prime top position and not the understanding of concept, then the issue starts. This is where the problem starts. So once the child understands the concept, then what I mean to say here is, once the child has understood the concept, then he will not lose the interest. Because if there is no conceptual understanding, then the child stops attempting questions. Once he stops attempting questions, he starts getting less marks. When the marks are less, he stops paying attention in the class, and his energy level or his mind starts diverting. When the mind starts diverting, it automatically becomes boring. But when the exams come, the anxiety seeps in, and ultimately the fear of mathematics builds up, and the child in higher classes drop this mathematics, and goes to other areas. So I would say, instead of introducing details first, think about it, teachers. Instead of introducing details first and then showing the child the big picture, we should start by introducing a big idea to the child. Just like the first few slides that I had shown at the starting of the session, of river delta, trees, and lightning bolts, and blood vessels and neurons, so that your interest builds up. So in the similar way, we have to build up the child's interest. And once the big idea is introduced, it gets interesting. Once it gets interesting, the child is motivated to work on it and is ready to indulge himself in inquiry mode. And then he starts to ask questions, why and how. Then the learning path should be decided by us as educators, where we introduce the details of concept, which is nothing but where the child goes into detail like definition, formulas, and equations. And when the child has sufficient knowledge, then he should be self-motivated to explore more of his own. So at the end, I would like to just end up my presentation with just one line. Maths is just a subject with a bad reputation. Otherwise, let us try to make mathematics more interesting for the child. With this, I would like to say a big thank you to all of you for being so patient and for being a part of it. I hope it was helpful to each one of you. Thank you. Any questions? Thank you, Preeti. Over to you.
Thank you, ma'am, for this enlightening session.
I hope
Audience,
it was
now
helpful.
we'll open the chat for you to put on your questions here.
Yeah.
So if you have any questions, please post it on the chat.
I hope it was helpful for each one of you, all of you. Can we use bar method for word problems? Yes. This is a question from
Padmavati, ma'am.
Yeah, very good evening, Padma ma'am. Yes, bar modeling is another.
Sorry, she's Anchal Midha. She has asked, can we use bar method for word problems?
Yes, for word problems, bar method is one of the parts of CP approach, Singapore maths. And normally without in word problems, the bar method is definitely used. And it's a brilliant way of solving any story sums. Any more questions? Preeti ma'am, it's going very fast. I can't see the questions.
Participants, if you have any more questions, you can post it on chat. Ma'am, we are getting so many appreciation from the audience.
Fractions very okay. You have now answered question on division of fractions. What?
So, Parmeshwari, Mr. Parmeshwari has written the two paper setting pattern was really good, but what type of hints can be given?
Now, the hints here definitely depends on the teacher. What are the things that my child is missing in the class? What are the things that it can be related to previous knowledge? The thing that you have to see it in your class is where is my class lacking? Where is this particular lot? Or 2-3 students are not able to pick up the word problems. So I would say, put a hint what you think is right, where you think your kid is going a little haywire. So it's not anything is specific. The way the child understands, we have to come down to their level to make question paper. Not, we can't have any specific. So I also made this pattern for myself because I could see in my classes, there were like 2 or 3 students always not ready with their thing, but I always used to help them out. So my aim was definitely the child is able to understand this concept in the higher and is able to use it in the higher classes rather than getting marks. And it used to be in knowledge of my seniors always, how I'm doing it. So yes, find out your ways of doing it. How to engage students with?
Yeah. So there's another question. Mr. Soma Sundaram has asked, division of fractions as to why it is multiplied by reciprocal.
Yes.
Please answer.
Yes, find out. You're a maths teacher. You know, if we do not know the meaning of why we have converted the division to multiplication and why we have taken the reciprocal, then I don't think so we are good enough for the teacher, being a teacher, because this is the basic question of a division. Here, the answer lies in the answer of definition of division. What does division mean? Division means how many parts. If we do it with a normal like 12 divided by 3, what does it mean? How many parts of 3s can fit into 12? 4 parts. Similarly, how many 1/4 can fit into 1/2? 2 parts. That's the, once the child has to see it in real life, then only we can say, okay, there's an easier way of doing it. That is by taking the converting the division to multiplication and by taking the reciprocal. So this is how we have to first clarify our concepts.
Ma'am, there's another question from Anchal Medha. Are statements necessary for bar method? And at what level
I'll tell you,
in one
Medha,
word
thank
or
you
sentence?
for this question. What is the second part?
And at what level in one word or the sentence?
I would say the child will definitely be interested in writing statements when he gets the answer. In bar method, without doing any proper calculations, we reach to the answers. And once, otherwise, child is more concerned about steps. But once the answer is there in the form of a bar method, then child will definitely be, interested in writing the answer. He'll do it. He'll understand. So that is also, bar method is an easier way of reaching to the answers.
Ma'am, there's another question from Nandana Das. So she has written, it is very difficult to make the long division of large number. Could you suggest some strategies to make it interesting?
What is the name of ma'am?
Miss Nandana.
Hi, Nandana. Good evening. I would say, Nandana, whenever you are explaining any concept, don't do it with large numbers. The concept of anything should be made clear to the child by taking smaller numbers. Always the concept should be taught. We take bigger numbers only to engage students. So calculation with bigger numbers need not be there when the conceptual clarity is there. Take it with smaller. Child is able to, because a larger number is very difficult for the child to visualize. Do the concept clarity only through the smaller numbers.
All right, so we are not getting any more questions here. I guess we can, wrap up the session now. So thank you so much, ma'am, for this wonderfully insightful session.
Thank you so much, Preeti ma'am, for being a support.
I'm sure these methodologies will empower all educators in their classrooms. Sure. I would also like to thank all the participants for joining. I hope you all found this session very informative and helpful. I would like to remind you all that we have another session scheduled after this at 4 p.m. today, where we'll be taking up the topic of suggested pedagogies for teaching math as per NCF 2023. So we'll be starting this session at 4 p.m. Please join in on time. And thank you so much, Saryu ma'am.
Thank you, Preeti ma'am. It was great interacting with you. Thank you.
Thank you, ma'am. Thank you. So see you all in the next session then. Thank you so much.